All right. Can my people on Zoom, can y'all hear me? Anybody hear me?
Yes.
Okay, great. Thank you. Okay, so before we get started for the day, I am going to kind of fill you guys in on what happened because I have tons of emails that are freaking out because they can't find Module 6. So, the module for week 6, which I too have no idea what happens. I am going to show you what I do. Okay, so in my classes, my courses, I have these things called sandbox. You see I have a geometry sandbox. So sandbox is like a place for us to play, like a child plays in a sandbox, okay? So we work in our sandboxes until we have it perfect, ready to go for our students, and then all we have to do is go from the sandbox you can copy to the actual course, okay? So I've got mine ready in my sandbox. I have everything ready for week 7. I copied to geometry, and for whatever reason, it totally like replaces week 6. So I don't know enough about coding with computers to know what happened. Apparently week 6 and week 7 had the same like underneath coding. And so what they thought I was trying to do was update my week 6. And so now week 6 doesn't exist. Okay, so I've called the hotline. So I wanted to get so you're going to see, and everyone's getting a 40 out of 40 for week 6. So I, at this point, have no way to check who turned in the homework, who didn't turn in their homework. So 6 is just a bust. Now, you know that we took a quiz in Edulastic. That all is still there. Okay, I didn't lose my stuff in Edulastic. I just lost the module week 6. So if you haven't submitted your stuff for Friday, people were like, I don't have anywhere to submit. Where do I submit? Don't worry about it. You're getting a 10 out of 10. You keep it in your textbook because you will still be tested over that material. Like it's not like it's just not going to be a part of our test. It's still going to be there. It still will be tested. You need the material. You just don't have a way to turn it into me. So I'm giving you grace and just saying you did it. You did it perfectly. You get a 10 out of 10. Whether you did or didn't, you get the points for it. Okay? So anything from week 6, don't stress over turning in, but do make sure you've got it. So if you were absent or for whatever reason you missed one of those lessons, you still want to get with someone, get the notes, and then you can always go to my YouTube channel. Okay, like if you go to any of my YouTube videos, you'll see Kristen Cole's YouTube channel, and you can go back and you can look at geometry from October the 2nd, geometry from October the 1st. So the videos are still there. Everything's still available. It's just not available to you in week 6 module, okay? So if you need the videos, just go straight to YouTube. If you need the paper documents, you can click on the virtual textbook. You can get the virtual textbook. You've got your paper textbook. Everything's still available, just not as easy as it was with week 6, okay? Any questions from you 5 or my virtual people that are listening? No? Okay, well, our plan for today is to be on lesson 7-3, which is on page 84 in your textbook. So we are going straight to page 84 in your textbook. My first hour was a train wreck, a complete train wreck. So I'm hoping that this lesson goes better. All right, let me get our textbook up. I restarted my computer over the weekend, so I need to get back to our Unit 1 stuff. I need the textbook. Okay, also for the virtual people and for you guys, tomorrow is a day where we won't be at school physically, but we will still be having school. So kind of just like Friday, I'm going to record your video and post it just as if we were in class. So for you guys, it won't be any different than what you would be doing typically on a B-Day. But for my B-Day students, when you watch this video, Just because you're not in the schoolhouse doesn't mean you don't have a lesson. So we are still going to be having a lesson tomorrow. You do still have to do that, do your homework, and submit it. You also have to do your attendance question. Okay, so tomorrow is still a school day. It's just not a in the schoolhouse school day. And I will be given the ACT, so I won't be able to really answer your emails super quickly, but I'll be able to get back with you guys tomorrow at some point. Yes. I'm trying to do 84. It's just not working with me. I think today is not my technology day. Okay. All right, so we're on page 84. We're talking about parallel lines. Perpendicular lines. So what we talked about on Friday when we were virtual and you guys watched the lesson, if you were able to, because some of you, like I did it, I made the switch at like 4 p.m. Some of you had not started your work. So some of you may not have even watched the lesson for 7-2. That's on YouTube. Okay, so go to YouTube. Watch the 7-2 lesson and make sure you get the notes for that because we did talk about proving parallel lines and we did that homework assignment. Okay, so that's all there for 7-2. So you can access that and get the notes. Now, 7-3 is talking about perpendicular lines. So our learning targets say that today we are going to develop theorems to show that lines are perpendicular, and we are going to determine whether lines are perpendicular. So everything we do today is going to be about perpendicular. Again, we're not really going to do all of the stuff with the patio and the bricks and all of that, but I am going to read you what they're talking about. It says, the second customer of Patios by Madeline has hired the company to build a patio with rows of bricks that are perpendicular to the walkway as shown. So perpendicular, if you look over to the math terms, says two lines or parts of lines are perpendicular if they intersect to form a right angle. So that's why when we say like the definition of perpendicular lines proves right angles, that's because it's in the definition. Okay, so the definition tells us about the right angles. So it tells us it's going to be 90 degrees. Now, we are not doing anything with the protractor, so we can skip to page 85. But before we do that, you guys look at those math terms at the bottom. Those are important. We're going to be using those postulates, so I want you to kind of pay attention to them. It says the perpendicular postulate states that if any given line and point not on a line, then there is exactly one line through the point that is perpendicular to the given line. So that is your perpendicular postulate. It tells you that if given a line and a point not on the line, then there is exactly one line through the point that is perpendicular to the given line. Let me give you a picture because that probably doesn't make a lot of sense. Here's our given line, okay? Here's our point. There's only one line that you can go through this point and intersect this line and make a perpendicular intersection. So like we can't go this way. Why not? It's not going to be perpendicular. Can't go this way, can't go this way. We literally have to go straight up until it forms a perpendicular line. So that's what the perpendicular postulate says. Same thing if the line or the dot were to be like over here. There's only going to be one given line. It would be right there. Okay? So if you have a given line and a point, there's only one line that will create that 90 degree. That's what the perpendicular postulate says. Then it says, likewise, the parallel postulate states that if given a line and a point not on the line, then there is exactly one line through the point that is parallel to the given line. Same thing. If this is my given line, And this is my point. There's only one line that is going to go through that point that's parallel to this. It would have to be that way because you would need them to have the exact same slope, okay? If we went this way, it wouldn't be parallel. If we went this way, it wouldn't be parallel. This way wouldn't be parallel, okay? So there's only one way that it could be parallel. Got it? So those are postulates, which are something that we can use when we are doing proofs, okay? Now, I want you actually to go ahead and flip to number 8, okay? Number 8 is going to give us a situation that's not dealing with Matt and his business, and it says that line segment RS is perpendicular bisegment, okay? So RS is the perpendicular bisector. So what's a bisector again? That's right. It cuts whatever it is, line, angle, segment, in half. And perpendicular means that it forms a 90-degree angle. So that's a lot of information in those two words of JL, line segment JL. Can you conclude that point K is the midpoint of RS? Explain. Why not, Skylar? That's right. Okay, I'm sure that you couldn't hear him, but he is exactly right. So it's saying that it is the bisector of JL. Okay, so since it's the bisector of JL, that means that K is the midpoint of line segment JL. It doesn't have to necessarily be the line segment or the midpoint of RS. And just because it looks like it doesn't mean that it is, okay? We never just assume things. We have to be able to prove it. Now, number 7 says lines A, B, and C lie in the same plane. If A is perpendicular to B and B is perpendicular to C, can one conclude that A is perpendicular to C? Explain, include a drawing to support. I'm going to let you think this one out on your own. Draw yourself a picture and see if you can figure that one out. Don't say your answer. All right, what'd y'all decide? Yes or no? Oh, wait, say that again? Because I think you're right.
No, because C cannot perpendicular lines instead of perpendicular lines.
Okay. Anybody else have a different thought? They're going to be parallel. That's right. Okay. So if you drew on a picture, the first thing you see is that A is perpendicular to B. So I'm going to let this be B and this be A. Okay. Are they segments or lines? They're lines. Okay. Then it says that B is also perpendicular to C, Well, in order to be perpendicular, it's going to have to create this angle. So I'm drawing a sloppy C, but that's where C would have to be, okay? Then it wants to know, could A be perpendicular to C? Well, that's not possible, like John was saying. So they are actually going to be parallel, okay? And so if they are both perpendicular to the same line, that means that A and C have the same slope because they're perpendicular to B. Well, if they have the same slope, then they are parallel, okay? All right, now we are actually going to work 9 through 13 together, and then your homework is going to be something separate. So number 9, we're looking at the instructions. It says in the diagram, L is parallel to M. So in this diagram, they're telling us that these two are parallel, okay? It says angle 1 is 90 degrees. And angle 5 is a right angle. So they're identifying this as a right angle and 1 as a right angle. Use the diagram for items 9 through 11. It says, explain how you know that L is perpendicular to P. How do you know that L is perpendicular to P? That's right. The measurement of angle 1 equals 90 degrees. Therefore, the lines are perpendicular. Number 10 says show that the measure of angle 4 is 90. How could we show that the measure of angle 4 is 90? Okay, so that's one way. Knowing that L is parallel to M shows it is 90 degrees. What's another way? Or the measure of angle 4 corresponds to angle what? 2? Aren't they corresponding angles? And the measure of angle 2 equals 90 degrees because it is a linear pair with the measure of angle 1. So you know that 1 plus 2 have to equal 180. They're a linear pair. So 1 is 90, therefore 2 is 90. 2 and 4 are corresponding. So that's another way to say it. But knowing that those lines are parallel, you know that they're going to share the same slopes, which means they're both going to be perpendicular, meaning all 4 of those angles on both sets of lines will be 90. Either way. Number 11, it says, go ahead. What would their degrees be? One and 2 are a linear pair because they form a line together. That's a good question. So see how they have that flat 180 together? So you call those a linear pair. Anything that's like that, like if it's a straight line and it's like this is angle 2 and this is angle 3. Those angles are linear pairs because they form that straight line together. Good question. Y'all got all that? Because I'm about to switch slides and get a new one. All right, so we're on number 12, right? 11. Show that our L and N are parallel. How can we show that L and N are parallel? The measure of angle 1 equals 90 degrees. And what other measure? 5 equals 90 degrees. Therefore, they are parallel. Because 1 and 5 are what? What type of angles? They're corresponding. Corresponding have 2 R's or 1? Okay, I was doubting myself. So since the corresponding angles have the same degrees, corresponding angles are congruent, that means that we have parallel lines. Number 12, the perpendicular bisector, so perpendicular 90 degrees, bisector, cut it in half. The perpendicular bisector of line segment AC. So we're on to a new situation, guys. This is not with this. We're doing something different. Perpendicular bisector of segment CD intersects CD at point P. If CP equals 12, what is CD? Not 12. Your whole segment CD. Okay, a perpendicular bisector gets it at point P. If CP is 12, what's CD? It's 24. You know that because you double it. Okay, then 13 says the angle formed by the intersection of 2 lines is obtuse. So the angle formed by the intersection of 2 lines is obtuse. Could the lines be perpendicular?
No, obtuse is more than 90 degrees.
That's exactly right. No, because obtuse angles can not equal 90 degrees. Okay, so that lesson just didn't have a lot of questions for us to talk about perpendicular angles. That's why I did the homework with you. So that means that you are going to be working the problems on page 88. Page 88, you'll see lesson 7.3 kind of at the bottom left-hand side, 7.3. You're going to be doing 18, 19, 20, 21, and 22. So you do have to do that proof. So I don't need you to submit the pages we didn't write on. Okay, so really we pretty much just wrote on page 86. So you can just submit page 86, what we did together homework-wise or practice-wise. So 86 practice, and then also the homework on page 88. No, you don't have to because we didn't really write a whole bunch. We just underlined some stuff, so I don't need that. So just those 2 pages is fine, 86 and 88. And like I see, like you're writing on a piece of paper. So if you want to just write all of the stuff on a piece of paper for page 86, just put page 86, draw a line, put page 88, and then you can just submit that piece of paper. Like you don't actually have to submit your springboard stuff if you wrote yours on a loose leaf sheet of paper. Okay, so whatever you did is fine. Just make sure I get both of those pages work. Does that make sense? Any of my people online have questions? Do you understand your assignment?
What problems are on page 88 that we do?
Okay, let me write that out because that's probably important. So page 88, hold on, my pen's lagging. Page 88, you are doing numbers 18 through 22 for homework. And those of you in class, y'all probably have time to finish that. You still have like 25 minutes with me. Okay, so y'all work on that for those 25 minutes. And then those of you at home, y'all get that finished, get that turned in. Anybody have questions for I log off? All right, don't forget, tomorrow is a school day. It is a school day tomorrow. Do your work virtually tomorrow and get it submitted. And again, I'm so sorry about week 6. I'm really so sorry. Is this chat? Do we have people in the chat asking questions? Okay, good. Sorry, Thomas. All right. See y'all later.